Okay, Year 12. We're almost at the end here with our lessons on polynomials. This YouTube clip's going to go through 7.5 polynomials, roots, and coefficients. So I've put in the syllabus document here, and the first thing we're going to look at is this bit here. The student is able to write down the relationship between the roots of coefficients of polynomials of equations of degrees 2, 3, and 4, which is quadratics, cubics, and quartics. Now, you already know this, and this is work that we've done in extension 1, but let's have a look. So we already know that in a quadratic, if the roots are, if we let the roots be alpha and beta, well, we can then expand that to x minus alpha, x minus beta. And then we expand that. Sorry, we can write that as x minus alpha, x minus beta. We're going to get x squared minus alpha x minus alpha, beta x plus alpha beta. And if we tidy that up, we'll get x squared minus alpha plus beta x plus alpha beta. And because the equation we started with was ax squared plus bx, well, if we take this equation over here, here's the equation we started with, ax squared plus bx plus c equals 0, but we don't want that coefficient in front of the x squared, so we'll divide everything by a, and we'll get x squared plus b on ax plus c equals 0. Now, we know these two things are the same, x squared plus b on ax plus c, so we can equate the coefficients. So b on a equals minus the sum of the roots, and I forgot my a here, and c on a is the product of the roots, and that's where it all stems from. So when we're talking about this, we've got sum of the roots which is alpha plus beta equals minus b on a, and the product of the roots which is alpha beta equals c on a. Now, you already know we can expand this. So for a cubic, I'm not going to go through the expansion. The sum of the roots, so we let the roots be alpha, beta, and gamma, and the sum of the roots, 1 at a time, so alpha plus beta plus gamma. Well, it'll always equal minus b on a. Now the sum of the roots, 2 at a time, alpha beta plus alpha gamma plus beta gamma will be c on a. And the sum of the roots 3 at a time, because there's only 3 of them, alpha, beta, gamma, ends up being the product of the roots, is minus D on A. And as you can see, we have alternating pattern here. So negative, we always start with negative, minus B on A, then positive, then negative, and so it will continue. So when we get to a quartic, I'm going to change the terminology here because I'm doing the sum, and we know we have a symbol for sum. Looks like that. So from a quartic, so if I sum the roots one at a time, that's a terrible alpha. So sum of the roots one at a time, that'll be minus B on A. Now if I sum the roots two at a time, I'll just use the symbol alpha beta, I'll get C on A. And if I sum the roots three at a time, so alpha beta gamma, alpha beta, add another root there, delta, alpha beta delta, alpha gamma beta, alpha gamma delta. If I'm adding all those, that'll be minus D on A. And as I go down to a quartic, I'm summing the roots four at a time, I'll go to E on A. And we could continue. We could go on doing this for any polynomial. So the syllabus says degrees 2, 3, and 4. So we're going to stop at 4. I imagine that they could ask you a question relevant to this in the HSC, but we're just going to do this. And we're going to look now at the example question on page 180 of your textbook. Now, with our extension 1 work on roots and coefficients, we do a little bit. We only do quadratics in mathematics. We do cubics and furthers in extension 1, cubics and quartics. But now we're going to go and do a little bit more. We're going deep into the quartic territory. So if I look at this one, and we've got this cubic, x cubed minus 2x squared plus x plus 3. And we've got to find, the first one, alpha squared plus beta squared plus gamma squared. So now I'm going to have to do a little bit of mathemagic here. And we've done this before with squares, but not with 3 terms. So alpha plus beta plus gamma all squared. Well, I can expand that. So I'll get alpha plus beta plus gamma times alpha plus beta plus gamma. Now 3 times 3, I'm going to get 9 things. So I'm going to get alpha squared plus alpha beta plus alpha gamma plus alpha beta plus beta squared plus beta gamma plus alpha gamma plus beta gamma plus gamma squared. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's get all the powers together. So I've got an alpha squared plus a beta squared plus a gamma squared. And let's get all the pairs. So you can see here, I've got an alpha beta, an alpha beta. I've got an alpha gamma and an alpha gamma. I've got a beta gamma and a beta gamma. So I've got 2 of each. So I've got 2 alpha beta plus 2 alpha gamma plus 2 beta gamma, which gives me alpha squared plus beta squared plus gamma squared plus 2 alpha beta, alpha gamma, beta gamma. And now you can see where I'm going with this. This is what I want. Alpha squared plus beta squared plus gamma squared. Here is the sum of the roots 1 at a time. Here are the sum of the roots 2 at a time, and I know what they are equal to. So I'm just going to write an equation now. I'm going to take that red bit, I'm going to put it, or I'm going to take this 2 alpha beta and subtract it. So alpha plus beta plus gamma all squared minus 2 alpha beta plus alpha gamma plus beta gamma equals alpha squared plus beta squared plus gamma squared. And I know what these are because that's minus b on a, and that's c on a. And if I look back at my equation, minus b is minus minus 2, minus minus 2 on 1, minus 2 times, and what's c? 1 on 1 equals alpha squared plus beta squared plus gamma squared, which gives me, oh, I've got to square that. I was really lucky. Whoops. So it's going to give me 4 minus 2 equals alpha squared plus beta squared plus gamma squared. 2 is alpha squared plus beta squared plus gamma squared. Okay, well that was pretty easy. Now, I'm just going to move this thing. The next part. All right, the next part, B, says find alpha cubed plus beta cubed plus gamma cubed. Now, I could go and do a long expansion of that, and there is a formula. Patel talks about it, but it's difficult and long. So what I'm going to do is I'm going to have a look at, I'm going to do a trick. So let's take this equation. What was it? X cubed minus 2x squared plus x plus 3 equals 0. That's the equation. We have roots for that. I'm going to take everything over the other side. So I'm going to get x cubed equals 2x squared minus x minus 3. I've just rearranged the equation. Now, but I know the roots. And the roots are alpha, beta, and gamma. So that if I put alpha in, it should equal the same thing. If I put alpha into that original equation, if I put alpha into this, it'll equal 0. So if I put alpha into this, I'll get the same thing. So sub alpha, beta, and gamma in, and I'll get alpha cubed equals 2 alpha squared minus alpha minus 3. And I'll do the same for beta. Beta cubed equals 2 beta squared minus beta minus 3. And gamma cubed, 2 gamma squared minus gamma minus 3. Now I can just, the 3 equations, I can just add them. So, therefore, alpha cubed plus beta cubed plus gamma cubed equals all these things added together. 2 alpha squared plus 2 beta squared plus 2 gamma squared minus Now I'll take the minus 1 out, and if I add these three things, I'll get alpha plus beta plus gamma. If I added them all, I get minus alpha, minus beta, minus gamma, but I'll take the minus 1 out and factorise it. And I'll get minus 3, minus 3, minus 3, minus 9. Let's take the 2 out of that, and I get alpha squared plus beta squared plus gamma squared minus 1 outside of alpha plus beta plus gamma minus 9. Now we already know alpha squared plus beta squared plus gamma squared. We just worked that out. It's 2. So I'm going to get 2 times 2. And alpha plus beta plus gamma, well, that's of some of the roots 1 at a time. And alpha plus beta plus gamma is minus b on a. So minus minus 2, so it's going to be 2. So minus 1 times negative 2 minus 9, 4 plus 2 minus 9 and negative 3. Sorry, that should be minus 2. How did I mess that up? Minus, minus, minus. Oh, yes, because that's going to be a plus 2. And my answer is negative 7. Righto. Let's have a look at C. And C says alpha to the 4 plus beta to the 4 plus gamma to the 4. Got to find that. Now, I can't do the same trick because I can't write x to the 4, can I? Because it's an x cubed. How can I get a quartic in here? Well, let's have a look at what we started with last time. Well, we know that x cubed equals 2x squared minus x minus 3. Now, that's an equation. We know it's true. That's the original equation. We've just rearranged it. We need x to the 4. Well, why don't we just multiply everything by x? And we'll get x to the 4 equals 2x cubed minus x squared minus 3x. And again, since we know the roots are alpha, beta, and gamma, we can just substitute them in. So, and we'll know it'll hold true. So alpha to the 4 equals 2 alpha cubed, and you can see where this is going, minus alpha squared minus 3 alpha. And we'll do beta. Beta to the 4 equals 2 beta cubed minus beta squared minus 3 beta. And of course, gamma to the 4, that's a bad gamma, 2 gamma to the 3 minus gamma squared minus 3 gamma. And again, if I add them, I'll get alpha to the 4 plus beta to the 4 plus gamma to the 4, which is what we want. I'm going to get 2 of the alpha cubes. 2 alpha cubed plus beta cubed plus gamma cubed, which we already know. I'll take out minus 1 and I'll get alpha squared plus beta squared plus gamma squared, which I already know, minus 3 times alpha plus beta plus gamma. So it all works out really nicely. So I get 2 times negative 7 minus 1 times 2 minus 3 times 2, which gives me negative 14 minus 2 minus 6, negative 22. So there are two tricks for doing the roots cubed and the roots to the power of 4. But the main thing is all of this really hinges on what you already knew from before. The sum of the roots 1 at a time, the sum of roots 2 at a time, the sum of roots 3 at a time, and so on as you progress down any polynomial. What I want to do now is I want to look at transformation. The transformation of roots, which is this stuff here. Use these relationships to form a polynomial of equations. So we're going to use the property of the roots to write equations of a different format. And these are the types we have to do. Equations whose roots are a multiple of the roots of a given equation. Reciprocals, so we've got a multiple. Reciprocals, they differ by a constant, so either adding or subtracting a constant, or squares. Now it sounds really complicated, but when you see this, it's unbelievably easy. And you should remember it from our work when we did functions about transforming or transformation of polynomial, transforming equations. So here we go. The easiest way is to do this by the example question on page 181. And let's have a look. So the first one, I'll just move this. The first one says, for this equation, all right, for this equation, the roots are alpha, beta, and gamma. So the roots are alpha, beta, and gamma. Now, in A, it says, find an equation for which the roots are reciprocals. All right? With reciprocal roots. And this is an easy transformation. So there's my original equation, but I want an equation where the roots are 1 on alpha, 1 on beta, that's meant to be a comma, and 1 on gamma. So all the roots are reciprocals. So if I had the equation originally, I could put 2 alpha cubed plus 3 alpha squared plus alpha minus 5, and that would equal 0 because that's a root. If I want the reciprocals to be true, I can now just sub in those reciprocal roots and I could get the equation out. So this is, since the roots are going to be reciprocal, I'm going to let y equal 1 on x. Hence, for my new equation, and because I want the equation in terms of x, if I rewrite this, well, x equals 1 on y. So everywhere, I'm going to substitute 1 on y into the equation. So I've got 2 times 1 on y cubed, because that's what x cubed is, plus 3 times 1 on y squared, plus 1 on y minus 5 equals 0. Now, I've got the equation, that's essentially it. But I'm going to multiply everything, because I don't like the y's on the bottom. I'm going to multiply by the highest power y. I'm going to multiply everything by y cubed. So here, Well, the y cubed will cancel, I'll just get 2. Here, I'll get 3y. Here, I'll get y squared. And here, I'll get minus 5y cubed equals 0. Now, if I take everything over the other side, I'll get 5y cubed minus y squared minus 3y minus 2 equals 0, which, if we rewrite this as an equation with x's, because it's the equation that has reciprocal roots, is 5x cubed minus x squared minus 3x minus 2 equals 0. And that's it. It's incredibly simple. Incredibly simple. So what about B? We want in B 2 alpha, 2 beta, and 2 gamma. So to get the right, what you're essentially going to do is you're just going to transform it. To get the right substitution, let y equal 2x. Hence, x equals y on 2. Now, everywhere in the equation where there's an x, you're going to put y on 2. So you see how simple this is. 2 y on 2 cubed plus 3 y on 2 squared plus y on 2 minus 5 equals 0. Now I'm just going to rewrite, expand all that. So I'm going to get 2y cubed on 8 plus 3 y squared on 4 plus y on 2 minus 5 equals 0. If I multiply everything by 4, because that's going to be y squared on 4, y cubed on 4, I will get y cubed plus 3y squared plus 2y minus 20 equals 0. And hence, therefore, the equation, if I now put x's in, will be x cubed plus 3x squared plus 2x minus 20 equals 0. And that, now think about what we're doing here. We're just rewriting the equation so that the roots are 2 times the original roots. In the previous one, that's the equation where the roots are the reciprocals of the original equation. So it's just transforming. And by transforming, we're rewriting x in terms of y. So C, as you can see, this is terribly easy. You should sort of be getting it now. C, what do we got? We want the roots to be 2 plus alpha, 2 plus beta, and 2 plus gamma. So y equals 2 plus x. Now you should be going, all right, well, that's easy now. I know what's going to happen here. X equals y minus 2. Now, everywhere there is an x, I'm going to put y minus 2. Y minus 2 cubed. 2 plus 3 y minus 2 squared plus y minus 2 minus 5. And now it just becomes algebra. So 2 y cubed minus 3 times that, 6y squared plus 3 times that squared. So it's going to be 3 times 4, so it's going to be 12y minus the last thing cubed. It's going to be 8 plus 3 outside of y minus 2 squared. Well, that's y squared minus 4y plus 4 plus y minus 2 minus 5 equals 0. So I get 2y cubed minus 12y squared plus 24y minus 8 plus 3y squared minus 12y plus 12 plus y minus 7 equals 0. Now if I tidy all that up, I get 2y cubed minus 12y squared plus 3y squared is minus 9y squared. 24y minus 12y, 12y plus another y, 13y, minus 8 plus 12 is positive 4 minus, oh, I've messed up here. Where's my other one? That's 2 8s, that's 16. 16, so minus 16 plus 12, yeah, minus 11. And of course, then we rewrite it in terms of x. Therefore, the required equation will be 2x cubed minus 9x squared plus 3x minus 11 equals 0. And that's the equation where the roots are plus 2. Okay. Let's go on to D. If I do D, x minus alpha. Alpha minus 2. Beta minus 2. And gamma minus 2. Well, you can see what we're going to do. We're going to let y equal x minus 2. Take it over. Y plus 2 equals x. And we're going to plug that in. So we get 2y plus 2 cubed plus 3y plus 2 squared plus y plus 2 minus 5. Now, to save time on the video, I have done that and you can look it up on my worksheets. You can look it up on Patel. It just pops out to be 2y cubed plus 15y squared plus 37y plus 25. And of course, we rewrite that equation with x. Therefore, 2x cubed plus 15x squared plus 37x plus 25 equals 0 is our required equation. And the reason I went quickly through that and I didn't bother with the expansion from this step to that step is because we need more time to have a look at what happens when we get E, which is a more difficult one. So let's have a look at E. Now, E asks for, what if we want alpha squared, beta squared, and gamma squared? Okay, so we let y equal x squared. And that's our first step. And you get the equation in terms of y and then just rewrite it at the end. So, what do we get here? Well, x equals root y. And we're only going to deal with the positive in this case because we're going to square it at the end, and that'll negate the negative. So I get 2 root y cubed plus 3 root y squared, well that's just going to come out anyway, plus root y minus 5 equals 0. So I get 2y root y, that's why our surds was important, 3 root y, 3y plus root y minus 5 equals 0. And immediately you're thinking to yourself, oh, I'll just multiply by root y. But if we do that, we're still going to have a root y in there. And we want to get this so that there are no surds. So let's bring the root y's together. So we get 2y root y plus root y. And we'll put that other stuff on the other side. So we'll take the 5 over and we'll minus the 3y. I'm going to take out the root y. So I'm going to root y 2y plus 1 equals 5 minus 3y. Now to get rid of that surd, to get rid of this surd, I'm going to square both sides. So we square both sides. So square that, we'll get a y, and we'll get 2y plus 1 all squared equals 5 minus 3y all squared. So I'll get y outside of 4y squared plus 2 times that's 4y plus 1 equals 25 minus 10 30y plus 9y squared. So I get 4y cubed plus 4y squared plus y equals 25 minus 30y plus 9y squared. Bring it all over to this side, 4y cubed minus 5y squared plus 31y minus 25 equals 0. Hence the required equation. Put the x in, 4x cubed minus 5x squared plus 31x minus 25 equals 0. Done. So that one was a little bit more difficult, but not undoable. And let's go to the final one, E, F. So F. I want the equation that has the negative roots. Negative alpha, negative beta, negative gamma. All the roots are going to be. So this is going to be a lot easier, I would imagine. Y equals negative x. So x equals negative y. Again, we just substituted in 2 negative y cubed plus 3 negative y squared plus negative y minus 5 equals 0. And can I please tell you, put your y's, your negatives in parentheses so you know what's going to happen. So it's going to be negative 2y cubed plus 3y squared minus y minus 5 equals 0. Take it all over the other side, get positive, so you get 2y cubed minus 3y squared plus y plus 5 equals 0. And therefore, the equation is 2x cubed minus 3x squared plus x plus 5 equals 0. And there we go. And they're the transformations. So what do you do again? Every time you have one of these, you see your first step, you let y equal it. 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 You rewrite the equation, or rewrite that as x is the subject. Everywhere there's an x, you put that new version of y in, do your algebraic gymnastics to get the new equation, and then resubstitute or rewrite the equation with x in it. So, just a quick recap. Let's go back to the dot points. Relationships with roots and coefficients of degrees 2, 3, and 4. That's okay. That's pretty easy. Note there were some tricks in there, particularly when we had alpha to the 4, beta to the 4, gamma to the 4, or alpha cubed, beta cubed, gamma cubed, and working those out. Using relationships for transformation to write equations of new polynomials where you have multiple roots, reciprocal roots, they differ by a constant, you add or subtract a value, or the squares of the roots. That's the last thing we did. So now what you have to do, you have to go and do exercise 5D, questions 1, 2, 3, 4, 9, 11, 15, and 16. And if you can get those done by the time that you return, we should be right. And we should be back on track and able to get through the next topics without having to do extra lessons. So good luck with those, and I'll see you next lesson.